In this video, we are required to find the integral of sine squared x dx, right? So guys, this question, let's agree it would have been easier if we were just integrating sine x. But now, because we have to the power 2, it becomes a little bit challenging. But you have to worry not, right? So guys, we're going to convert this using identities, right? Remember, we have cos 2x equals to 1 minus 2 sine squared x. Ne? The reason why I chose this identity is because it gives me a cos that is to the power of 1, which is easier to integrate, and it also has a sine squared x, which means I can easily replace that. Right, do you see why I chose this identity specifically? Right, perfect. So from here we can now do this. We are going to move everything and isolate the sine squared x. So I have cos 2x, I'm going to have minus 1 equals to negative 2 sine squared x. All right, and then obviously, so that this for sine squared x to be alone, I need to divide everything by negative 2. So divided by negative 2 divided by negative 2. All right, then let's see what does that give us. Here I'm going to have negative, actually let's do this guys. I'm going to bring this guy on front because it's positive. So I have positive 1 over 2 minus cos 2x over 2. All right, because remember this will be a negative, it will come here on front, right? Perfect. And then this is basically this is equals to sine squared x. Why? Because this negative 2 will cancel with that one, which means where I see sine squared x, I can replace by this, right? Which will be easier to integrate because now we eliminated to the power of 2. So for trig functions, you always need to eliminate if you have to the power of 2, unless you have the cosec squared or the sec squared, because those derivatives exist, right? For example, tan x is derivative, it's sec squared x. And then cot x is derivative is negative cosec squared x. So those are the only two trig ratios that you can work with in terms of squares. But the rest you'll have to use identities to convert them. Ne? Perfect. So now I'm going to replace this with that in the integral. Right. So it's like I'm now looking for the integral. For the integral of, okay, let's see, integral of half minus cos 2x over 2 dx. This is what I'm now looking for. All right. This part is sorted. The derivative of a constant is easy to get. I mean, the integral of a constant is easy to get. But let's look at here. Right. This is cos theta basically, or cos 2x. Ne? But if you think of the 2x as theta, so we have cos theta basically. So guys, remember, inside the integral is the derivatives basically, right? So this was is a certain function derived to give us this, ne? But there's something missing here, guys. When we derive this, we use chain rule. The derivative of this must always be here, ne? The derivative of the angle must be outside there. So our angle is 2x. So the derivative of 2x will be how much? I'm going to use an orange one. The derivative of 2x will be 2 basically. So because I introduced the 2 there, I need to introduce a 2 at the bottom so that I don't change the meaning of the equation. Ne? Sharp. So remember, when you are dealing with trig ratios and you are integrating, you need the derivative of the angle to be multiplying the ratio. Sharp. Because that is what we do when we differentiate. Perfect. And then let's proceed now. So here we have we have integral of half dx minus integral of 2, okay, the 1 over 4 at the bottom. Remember, this guy here becomes 4, né? So I'll say 1 over 4 there. And then on top, I'm just left with that because the 4, I took it out there. Sharp. So I have 2 cos 2x dx. All right. Now let's see. Here I'm going to have equals to, remember here you just introduce an x, né? Sharp. And I always check myself. I know that the derivative of this must give me that, which is true. So I know that that is fine. And then I have minus 1 over 4. Obviously, the derivative of, the integral of this is sine 2x. Right? That will give us sine 2x dx. Right? Not dx, sorry. Sine 2x plus c. I meant to say plus the c. Remember, this is indefinite integral. You always add a c, right? Sharp. And then I always verify my solution. Let's check here. If I derive sine, I get 2 cos times the derivative of the angle, which is 2. So I get 2 cos x. So which means I integrated properly there. The 1 over 4 is still there. And then I have to add a c because this is an indefinite integral. And that's it with this video, ladies and gentlemen. Thank you very much. Aluta continue.